Today's topic is decimal expansion of rational numbers. Now, before actually starting the topic, let us get a quick recapitulation of the terms used in our topic, that is decimal expansion and rational numbers. Now, as we say rational numbers, the definition quickly pops into our mind, which is numbers which can be written in the form of P upon Q, where Q is not equal to 0. Right? And when we talk about decimal expansion, what comes into our mind? That decimal expansion can be terminating or it can be non-terminating. Now, terminating means which can be finished. है ना, जिसका decimal expansion खत्म हो जाता है. Like this. And non-terminating means जो decimal expansion finish नहीं होता है ना. तो अब आपको याद है, आपने नॉन टर्मिनेटिंग डेसिमल एक्सपेंशन पढ़े हैं. दे आर ऑफ टू टाइप्स. वन इज रिकरिंग और रिपीटिंग एंड द अदर वन इज नॉन रिकरिंग और नॉन रिपीटिंग. Recurring means in which a particular digit or a set of digits keep on repeating. Like for example, if I have taken this 3.3, okay, 3.3 bar. Bar means repeating. So it's like when we divide 10 by 3, we get 3.3333 so on, and this can be written as 3.3 bar. Okay, now when we talk about non-recurring, non-repeating decimal, what are those? Those are in which the decimal expansion keeps on continuing, means it does not terminate, but there is no continuity in the digits. Each time you will find a new set of digit or a new digit coming. So these are a few examples. Okay. Now of these, the terminating decimals and the non-terminating recurring decimals come in the category of rational numbers. But on seeing a fraction or a rational number, how can we say that it will be terminating or non-terminating repeating? This is our today's main topic. Let us see how we do it. If I ask you that I give you a fraction and tell me it is terminating and non-terminating, how will you find? You will say, very simple ma'am, we will divide. Yes, you will divide. If I say 11 upon 2, you will simply divide it. You will say 5.5. Ma'am, it is terminating. But now if we have a larger number or even larger, then it is very time consuming to divide, to go step by step and then to find out that whether it is terminating or non-terminating repeating. So to help us with this, we should definitely find a shortcut. Okay. So now today we will find out a shortcut to find that how we tell that a given fraction will have a terminating decimal expansion or a non-terminating repeating decimal expansion. Okay. Now for this, let us take a few examples. See, I have taken a few rational numbers, 7 upon 2, 64 upon 45, like this you can see. Okay, and I have found out their decimal expansions by simply dividing. Okay, by the simple division we do, I have found their decimal expansions. Now, if I see the decimal expansion more particularly, I see some of them are terminating, while some of them are non-terminating. Okay. If I go back to my fraction, I find out like 7 upon 2. These 7 and 2 are co-prime numbers. They are in their simplest form. If I go further, I see 64 upon 45. These are also co-prime numbers. They are in their simplest form. 15 upon 1600. Now, both of them come in table of 5. They are not co-prime. So let them be cancelled and we must find out the simplest form of their fraction. Here also this can be cancelled by 3 and this can also be cancelled by 3. Okay. Now, after finding the lowest form of the given fraction, I am going to find out what is the prime factorization of their denominators. So I do the prime factorization of all the denominators. Okay, so now I find out that those denominators which had 2 or 5 or 2 or 5 both have terminating decimal expansion, while those which have any other prime number except 2 or 5 are non-terminating. Yes, this is what we were looking for. If you will do more practice, or if you will solve more examples, you will easily find out that if the prime factorization of the denominator has only 2 or 5 or both, then it is terminating. Else, if it has any other number except 2 and 5, okay, then non-terminating, repeating. Alright, so what we can say when the prime factorization of the denominator consists of 2 or 5 or both, then the decimal expansion is terminating. When the denominator consists of any other prime except 2 and 5, then it is non-terminating, repeating. Okay, so with this we generalize to the statement which is theorem 1.6 of your book, that let x is equal to p upon q be any rational number such that prime factors of q are in the form 2 to the power n dot or multiply 5 to the power m, where n and m are non-negative integers, means it can be 0 but it cannot be in minus, then x has terminating decimal expansion. ओके हमने प्राइम फैक्टराइजेशन किया डिनोमिनेटर का q का, अगर उसके प्राइम फैक्टराइजेशन में हमें सिर्फ 2 या सिर्फ 5 या 2 और 5 यही दोनों सिर्फ मिलते हैं, तो हमारा जो डेसिमल एक्सपेंशन है वो क्या होगा, टर्मिनेटिंग होगा. और अगर हम प्राइम फैक्टराइजेशन करते हैं q का and the prime factorization of q is not in the form 2 to the power n, 5 to the power m, where n and m are non-negative integers, then x has non-terminating recurring decimal expansion. Okay, so what are the things you have to remember before solving a question or before giving your answer? First, we have to change our particular fraction into lowest terms, ये बहुत ज़रूरी है. और second, what we have to do? We have to do prime factorization of denominator. Okay, so with this you can tell that whether the decimal expansion will be terminating or non-terminating. अब इसी टॉपिक से रिलेटेड एक और सब टॉपिक है हमारे पास बच्चों, that when decimal expansion is given, okay, decimal expansion is given और वो क्या है, वो या तो टर्मिनेटिंग है या नॉन टर्मिनेटिंग रिपीटिंग है. यानी कि अगर वो किसी रैशनल नंबर का हमें डेसिमल एक्सपेंशन दिया है, तो व्हाट कैन वी से अबाउट द प्राइम फैक्टर्स ऑफ q. ओके, तो इफ यू रीड दिस स्टेटमेंट ट्वाइस, you will easily generalize that this is the converse of what we have studied earlier. है ना, हमने पढ़ा था कि अगर किसी भी फ्रैक्शन के डिनोमिनेटर का डेसिमल एक्सपेंशन 2 to the power n इंटू 5 to the power m के फॉर्म में होता है, तो उसका डेसिमल एक्सपेंशन क्या होता है, टर्मिनेटिंग होता है. ठीक है, तो अब अगर डेसिमल एक्सपेंशन टर्मिनेटिंग है तो क्या हो जाएगा, q का प्राइम फैक्टर्स 2 to the power n इंटू 5 to the power m. चाहे कान ऐसे पकड़ो चाहे ऐसे पकड़ो, both will be true for each other. ओके, सिमिलरली विल बी फॉर नॉन टर्मिनेटिंग रिकरिंग. अगर आपको ऐसा डेसिमल एक्सपेंशन दिया है जैसे ये मैंने आपके लिए एक एग्जाम्पल लिया है 0.120, 120, 120 एंड सो ऑन. तो यू कैन सी इट इज़ 0.120 बार, यानी कि नॉन टर्मिनेटिंग रिकरिंग डेसिमल है. तो यू कैन सी दैट it will have what prime factors other than 2 and 5 in its prime factorization. Okay, so this is how you can find out that whether the decimal expansion of a given rational number will be terminating or non-terminating repeating. Now you will get a better idea when you will do more practice for the questions of this topic. So related will be the questions. Please solve it and get your expertise. Thank you.